Okay, good morning and good afternoon to our West Australian viewers. Welcome to the ASEG Webinar series hosted today by the ACT. I'm Mike Barlow, and today we are welcoming David Upton, journalist and geoscientist, who's going to talk about helping explorers find the nuggets in pre-competitive data and research. Before I introduce David, I just want to go through some housekeeping and some marketing for ASEG, please. Firstly, none of this could be possible without our corporate sponsors and sponsorship throughout the ASEG. Corporate sponsors including HiSeis, Total Seismic, Belsize, Southern Geoscience, Santos, Transparent Earth Geophysics, and Doug. If you have any questions, and please feel free to ask questions throughout, please use the Q&A as opposed to the comment section, and we'll have a Q&A section at the end of the presentation. Just to let you know about some upcoming webinars as well. Tomorrow, Peter Gunn is talking about the explanation for the distribution of Broken Hill style mineralization invoking dense rift-related igneous intrusions. Next week, we have Tiagan Blakely and Helen McFarlane interpreting high-resolution aeromagnetic data to aid mapping undercover and structural analysis of the Tanami region and northwest Illyrian province. Tuesday, 30th March, as part of the ACT-ASEG AGM, we have Dr. Richard Blewett talking on a personal reflection on applied geophysics to the understanding of Australia's geology and mineral potential. And then on the 7th of April, we have Jack McCubbin using airborne gravimetry data to improve the Australian model of zero heights. All of those presentations, I believe, are free for register, and the advertisements and registration links have already been sent out. Okay, going forward, if you're not a member of the ASEG already, keep in mind all these goodies that you get as part of that benefit system. Please just keep that in mind. Social events, reduced entry to AAGC conferences, free copy of preview, free access to exploration geophysics. Well worth the money per annum. And by all means, keep in touch through our Facebook, through Twitter, through LinkedIn, and through YouTube. Okay, so David Upton completed a BSc in geology at Flinders University in 1985, but chose to write about resources rather than look for them. After several years as business journalist, including a stint at the Sydney Morning Herald and The Age in Sydney, he veered off into the murky world of public relations, working for banks, accounting firms, and management consultants. David came to his senses in 2007 when he started writing about mineral exploration. A self-published book released in 2010, The Olympic Dam Story, sparked a fascination with big exploration concepts and the unappreciated value of pre-competitive data and research. A decade later, David began publishing Pre-Competitive Review. Okay, so I'll hand it over to David. Please remember the Q&A session down the side, and we'll have some time at the end for answering those questions.
Thank you very much, Mike. I'm just sharing my slides. Hopefully that is coming up for you. I'll try again. How does that look? Sorry, are you there, Mike?
Yeah, I'm here, David. Still no success yet.
Oh, okay.
Yep.
I'll go through the whole share screen setup. Hang on.
Yeah. Sometimes you have to be patient.
I see.
Yep. Bingo, you've got it. All right.
Oh, well, it's the first time for everything there.
Actually, it's still in draft mode, David. Just try again. Yep.
Is that working okay?
No, it's gone back to draft.
Okay, damn. Okay, does that work?
Yes.
Okay. Well, that's very good. Thanks for that. I think I've made my life a little bit more difficult because I can't see my notes now. But anyway, we'll manage regardless. So look, thank you very much for allowing me to talk to the ASEG. It's great, and I'm really delighted to have that interest in what I'm doing. I thought I might just talk a bit of a step back through history to see how I got here and what I'm doing. So it'll hopefully provide some interesting history, a bit of geophysical history too, in the search for copper, particularly with Western mining. So let's go. So I thought it might be interesting, and this looks like a plug for my book, so maybe it is, but it's really this book really started my fascination with pre-competitive, and I think most people don't appreciate that Western mining had 20 years of frustration looking for copper. From 53, they said, we're not going to hang all our fortunes on gold. We need to find other things, and they had incredible success. They seemed to be able to find ore bodies at will. They found bauxite, they found iron ore, they found nickel, of course, famously, and also uranium at Yeelirrie. But despite, since 57, wanting to find copper, they really had no luck whatsoever until Olympic Dam almost 20 years later. And what fascinates me about it is Western mining was sort of doing what is now pre-competitive science, within the company. They started at Taraji River, north of Broome. In fact, the base camp was all the way up at Derby, or is it Derby? That was in, and they were doing interesting things too, with working with BMR on what Roy Woodall called a colorimetric test for stream samples. And they were doing innovative things. They went to Moonta in the late 50s and brought in a company called McFar Geophysics to do this newfangled thing called induced polarization, and that was in 1960. So they were trying anything and everything they could find without success. Not long after Moonta, they went to the Warburton Ranges, way up in the heart of WA, where there were very high grades of copper in vein systems, and they were trying to understand that. And they even went to the Hamersley Ranges with a sediment-hosted copper model analogous to Africa's copper belt. So, they were trying everything over many years. It couldn't really find an answer. And then in the best mold of pre-competitive, what did they do? Well, they went back to university, and a young geologist, Douglas Haynes, he was interested in copper. He'd been to Warburton, was fascinated by those high-grade copper veins and just what was the genesis of that. So failing all that, he went to ANU in 69, started a PhD, and it was really just to find a pre-competitive advantage, a competitive advantage doing pre-competitive type of work that wasn't being done at that stage in the way it is now. And I've highlighted this not because Douglas is my hero, but because it's the essence of it. They really did reinvent entirely the search for copper based on research that Douglas had. It was just seeing, what happened to the copper when magnetite was converted to hematite in these mafic rocks. There was a known sort of association that copper seemed to appear with altered mafics, excuse me, but no one really knew if that was just a coincidence or if there was a real mechanism there. Excuse me, I'll grab a drink. Anyway, Douglas went to university. He was on half pay for 4 years. Again, Western mining investing in research in wonderful ways all those years ago, and it established a brand new model for copper exploration for Western mining. And I'll just head on to the next slide. So that was a really microcosm of what is going on and what you see now. You know, you see examples of Western mining's endeavours in the pre-competitive activity of today. So, you know, I'm still looking at things, and from 2007, writing about discovery, and particularly Olympic Dam. And 2016, the magmatic nickel copper prospectivity map came out. And in my brain that said, this is just the kind of thing that Western mining was doing. You know, this is what you need to do if you really want to find a competitive advantage and make new discoveries when they're not happening. And so that was a really big trigger for me, in addition to all the work that, you know, Western mining had done and understanding just how powerful it was. I should mention too, there was at Olympic Dam, the model of copper being driven out of magnetite was really fundamental. But so was the geophysics at that point as well. And South Australia had established, the Geological Survey in South Australia had established a geophysics department in 1948, which was about 10 years before any other state. And they were very, very keen on that. The Premier, Tom Playford, was very big on discovery, which was an amazing thing and an amazing legacy that the state still enjoys. So there was there was magnetic data, I think aeromagnetic data, yeah, flown in DC-3s by the BMR as early as 1961 across what would ultimately become Olympic Dam. And there was a gravity survey taken in 1969, which was just 4 years before Western mining would start looking at that area as one of, you know, half a dozen places around Australia. You know, they came back, Douglas Haynes came back, and he had an idea that they now needed to look for altered basalts, which was great because the geophysics would help them find the source of the copper. And, you know, it was a really significant development. And again, they started with the whole continent. They were looking right around Australia. Where can we find altered basalts that might be sources of copper? And they had a book by Jermaine Joplin that told them about the geochemistry of altered basalt. So they were drawing on really, really interesting and important pre-competitive geochem and geophysics. But they were doing the national search for themselves and working out where to go, what region, even what state. But here we have, you know, all these years later, me seeing this prospectivity map from GA and thinking that's exactly the same thing. This is really important. And then later, last year, I'm just fascinated to draw the parallel between the metal leaching of mafic rocks in the MacArthur Basin and that wonderful study that has worked out there's just so many thousands of millions of tons of zinc unaccounted for up in that location. So it's really exciting stuff, and there's all sorts of parallels between that. And it seemed to me, how can I help industry make better use of this incredible data? So the idea was to put together a website, which I've called Precompetitive Review. I thought a database would really be the solution to this job of helping explorers sift through all the information that was available. You know, it's not a question of just the way governments are communicating it or their channels. It's really just too much material for explorers to keep on top of when they're really just worrying about how to get a permit, you know, for that project next month or whatever. So I thought, yeah, database will do it. I'll put it all together. I've got about 125 things in there, and it's easy to search. And there's a you can look at the type of product. So if you want to find anything to do with, say, MT surveys that are ongoing, you can look that up. You can find all the prospectivity maps, and there's quite a lot of them. You can quickly find anything to do with nickel or anything to do with sediment-hosted base metals. And there's page links for all of these things, well, most of them. to help you learn a bit more about why it matters. So I did that, and the model is it's a subscriber site, so people pay an annual fee to get to access that material, and it's free to government geoscientists. So if anyone's in that category and they're listening and they'd like to have access to the site, just let me know through the contact page, because it would be silly to charge you people, for the benefit of my interpretation of what you're doing. But I just didn't want there to be any barriers between the people that are so important to what I'm trying to generate from. So the site's been up and going for about 6 or 7 months, and quite quickly it emerged that the database wasn't really what people were interested in. I still think it's there, it's valuable and it's important, and I certainly use it to keep myself organised. But I thought I would just be doing a little note every couple of weeks saying, here's what's new in the database and this is why. And anyway, those little notes grew and grew and grew into sort of major stories. And it turns out the latest news page, or just good old-fashioned editorial effort, is what people want. And I posted a couple of pieces yesterday. One of those, the isotope data suggests major new metals corridor in WA. Now, that's a really important piece of information that was in a presentation about a month ago via Yongjung Liu from GSWA. And he very kindly talked to me, explained a bit more. Simon Johnson talked to me, explained a bit more, and really just became obvious to me this is really significant. There are a lot of parallels why we found these juvenile corridors before and why they're so important. And it's not something you can just dismiss. So I ended up writing quite a long piece about that. And that's what is really helping people get to the nub of what is important for them. So latest news is the core of the site now, and I put new posts on there. I try to put 4, 5 or 6 posts every fortnight as best I can. So that's where it's going. The other thing is, I've just wanted to highlight this story as an example. The beauty of me not working for government is, and being a journalist and sort of being able to wax lyrical or, use a bit of, I won't say tabloid journalism, but I will say some more looser descriptions. I really can just try to cut through things. So rather than sort of a report with a difficult sounding name and fairly conservative and reserved analysis, I can just sort of cut to the chase, as it were. And this is an example where I put the headline on this story, and Kate Robertson might remember this. I just said GSSA nails it in the Delamerian. You had done a couple of MT transits, and you absolutely did. It was a fantastic result, and it just needed to be declared. What a great effort. And this is sort of the journalism, I guess, I'm bringing to Precompetitive to get some cut through. And it seems to be appreciated and working and helping really busy people in industry get to the nub of what's going on, why does it matter, where does this fit in the scheme of things. So yeah, that's where we're at. So moving on, I thought it might be interesting to look at some preliminary work I've been playing around with to look at, well, how important is pre-competitive? Is it really making a difference at the moment? And the answer is yes, it is. I've got this table here, kindly supplied by Richard Shoddy from Minex Consulting. It's his list of major discoveries, I think, or discoveries of all kinds, actually, since 2018 in Australia. There's a little bit of a modification there. The Cayley line is my addition. It didn't fit into his list really just on a technicality. It was there because of Thursday's Gossan, but until we get some reserve numbers out of Cayley, it doesn't come into his sort of contemporary discoveries list, but that'll happen. So I looked at this. I looked at the list of 2018 to 2020, And if you look at that, and this is my calls, and it might be controversial and it'll probably be debated, but hey, I'm allowed to editorialize, so I'm going to do it. I think there's 7 discoveries out of the last 21 in the last 3 years where pre-competitive has been a key factor. And I'll take you through those quickly. Julimar, absolutely was pre-competitive a key factor. And I know this talking to the managing director there, and for a story I wrote, he was a little bit cagey about things, but yet, yes, absolutely, the nickel copper prospectivity map was an influence in getting to that location. Subsequently, I've been talking to other people about this, and actually isotopes, a juvenile isotope corridor in that part of the world, which was, I understand why that was a hot spot in the nickel copper prospectivity map in the first place. Chalice really understood that significance and that there might be an entirely different exploration model here. So no doubt about pre-competitive being crucial in that. Napakara, I don't even know if I'm pronouncing that properly, but I've said yes to that. And I've said yes to all the discoveries in the Patterson in the last 2 to 3 years because of that 2007 Patterson AEM survey. Talking to progressive explorers up there, that survey was absolutely fundamental in opening up the Patterson to the big wave of exploration and success that's happening now. So that's why Napakara is on my list as a yes. Hemi is on the list as a yes because of GSWA's fantastic work with the geochem and synucleoids, which might be an unfamiliar word to you, but it will become much more familiar over the next few years. That's pivotal work, which was absolutely pivotal in making sense of the Taorana deposit that De Grey Mining had up there and leading them to Hemi and the greater Hemi area. So it's not shouted from the rooftops, but it was vital. Cayley, of course, yes, that's all part of the Western. It wouldn't be called Cayley, would it, if pre-competitive wasn't pivotal there. Going down the list, Havieron, another Patterson discovery that I don't think would have happened without that opening up of the Patterson with the 2007 AEM. Going down the list again, Oak Dam. Oh, that's controversial, but I wrote a story just last week talking. Jamie King's talked to PDAC, and I was surprised. He was very clear about the importance of Roger Skiro's mineral systems modelling work from 2019 on IFCGs was really fundamental to how they were going about things, probably from earlier than 2019, of course, but and they, of course, there was their own incredible effort to do the geochem with Olympic Dam. So that might be a bit controversial, but I think it deserves a yes. And then Patterson's down the bottom as well as another one. So 7 out of 21 is a pretty good effort, I think, and especially given that really we're only just starting to really lift the game. I think we're about to get into a whole new chapter. I will mention there, Salt Lake Potash has 1, 2, 3, 4, 5 listings from Richard's list. I know GA did a big study on potash potential in that part of the world. I have checked with that company, and they actually said they went in there before that happened. So anyway, this is part of the fine details of coming up with a definitive list, but I think it's a very helpful starting point to see that pre-competitive is playing a major role even now. Closing remarks. What will that table look like 10 years from now? Well, here's a prediction. I actually think that probably 2/3 of those discoveries will have pre-competitive as a key factor rather than 1/3. Why is that? Well, it's not just because of the fantastic work that's going on with EFTF and MINEX CRC. It's really thanks to East Tennant. I mean, if I had written this presentation a month ago, I probably would have been agonizing a bit saying, yeah, is industry going to pick this up? And are they really going to get this idea of how important it is to take advantage of the pre-competitive? And after East Tennant, I mean, that's been a game changer, as they say. It really has startled and surprised and delighted industry into the value of what's going on here. So I think from this point forward, there will be much more effort to follow what's going on. And what is going on? Well, incredible amounts of work and investment and innovative things, EF, TF, MINEX, CRC, which is really just starting a 6-7 year program of drilling. I mean, maybe not everyone's going to deliver results like East Tennant, but they will be delivering incredible results from undercover. That's what's going to happen. And look, yes, I would like to think with a bit of help from pre-competitive review, maybe the information will be more accessible, and there'll be perhaps a bit of a better understanding of just how much this can change things for explorers and give them entirely new exploration ideas, models, regions that really change the game for them. So that's it from me. Thank you very much for listening to my little story about pre-competitive review.
Great. Thank you very much, David, for that incredible insight into pre-competitive data and research. Look, and I also acknowledge the great stamp of approval you've given to GEA's work and the work of the state geological surveys as well. Look, before I throw a few questions to you from the audience, I have a question for you.
Yes.
You mentioned about how valuable the Patterson Airborne EM survey was in leading to discoveries. Would you like to put your name on the line as to where the next set of Airborne EM should be acquired?
That's an interesting question. Well, look, I sound like a complete suck, but I actually think that the next batch is in that southern half of the corridor, that eastern corridor for EFTF2. And I think that's probably a brilliant place to start. It's great to see it coming down to southern Australia, obviously, for the first time. And really what a fascinating part of the world that is, with the Delamerian, the Mount Wright volcanics, the Coonenberry Belt. I mean, it looks like it should be a fantastic place to explore with volcanic arcs. And we just don't know the first thing about it. So I think the AEM down there is a brilliant place to start. And that data will be out hopefully. Well, I don't exactly know when, but the flying is starting next month. So we will see things coming through very soon. I mean, EFTF second phase is a 4-year program like the first one, but that doesn't mean we have to wait 4 years to get some incredible information out of it. So it's being collected already.
Good, thank you. Look, we have a question here from Anonymous. It may be useful to track, well, great talk, David. It may be useful to track leverage, the ratio of value to initial investment in pre-competitive data. I suspect this would bring insight to the mineral exploration business. What do you think?
Yeah, it's not a concept I know much about, so that sounds interesting. Yeah, I think if leverage means the studies that government have done that looks for, for every dollar invested, we get this much return. I think those things are important, but I do think maybe people have a bit of a hard time not believing them, but just seeing that, well, is that really working? How does that work? The end of the day, it's really just about, shiny sulfides and drill core and discoveries. That's what really makes people think, wow. And wouldn't it be great if we get a discovery in East Tennant and an ore body? So yeah, it's certainly worth looking at, and one of the whole toolkit, I guess, we need to really persuade people that pre-competitive is just so important.
Okay, good. Look, we have a lot of questions flowing through now. So thank you for the talk, David. You mentioned the success of the Patterson Airborne EM survey. What do you think would happen if a more closely spaced, say, 1 to 5 kilometre line spacing was used for airborne EM surveys? And this is a question that often comes up to Geoscience Australia as well.
I think that may yield more information, but I do think it's appropriate. I think the 20 kilometre spacing is the right spacing for, covering vast swathes of Australia at a very broad level. Give us a foundation data set to see, I mean, in the Paterson region, for example, and I think that was spaced a bit more closely than the 20 Ks. So that's not the greatest example, but AEM1, ASEG 2, you get to see the trends in the strata, the rocks, the depth of cover. That's fine. And I think industry really ought to infill that more of it on its own. I'd wait for the 20 Ks to come out, unless you've got a really good idea that you want to zero in on an area where that's happening to fly anyway. Maybe get in on the infill opportunities up front, but otherwise, I think it's probably better the role for industry to infill at the 5 Ks and less.
Okay. From Anthony Schofield, from your research, would you like to comment on what kind of pre-competitive data set have been the most valuable in helping facilitate discovery to date, and which data sets are emerging as the most valuable moving forwards?
Yeah, that's a good question. Well, I guess you'd say AEM has been the most valuable so far in the sense that if you believe me, and it's not just me talking, it's people in the Paterson say that 2007 survey was absolutely pivotal to what we're seeing now, which is what, 13, 14 years later, so maybe that's a long lead time. I think AEM historically has been the major success story to here, but looking at East Tennant, I mean, that's just an incredible effort to go out to a area as barren as the Nullarbor Plain and find, drill hit sulfides and understand the lithosphere there. I think that's going to be absolutely the pivotal work that will change the game.
Okay. We have a question here from Carol. Hi, David. I would be surprised if any exploration in Australia occurs without using pre-competitive data sets. Here, I refer to at least geological and geophysical maps. What are your thoughts?
Oh, that's right. Yes, Carol, I'm sure you're right. Everybody looks at those foundation data sets for sure. So I guess in some senses you can say pre-competitive is a part of every discovery. So that's a fair point. And it's a question like where do you draw the line? Like I've said, 7 out of those 21 are where something has made a key difference. I mean, but maybe none of them would happen without those foundation data sets. So maybe it's a matter of how I'm looking at it. I mean, even Olympic Dam wouldn't have happened without the gravity and the magnetics that were in that region. So yeah, maybe it should be 100%, not 1/3. It'd be interesting. It's interesting to work out a definition here, because I think it would be good to put a bit more effort into a list like that and try and demonstrate things. But that was just an initial go for my own amusement.
Okay. And a question here from Ned Stoltz, Dr. Stoltz. What is more important, the pre-competitive data to map geology or pre-competitive data that detect mineralisation or detect vectors to mineralisation?
Geez. Well, they're both important, but at different scales, I guess, aren't they? The pre-competitive that tells you about the geology will get you to the camp scale. The pre-competitive that tells you about the mineralisation and the vectors will get you from there down to something less than that, prospect scale. So they're both important, and this is the trick. I mean, it's a really complicated thing, making discoveries, isn't it? Fascinating to me. One of the, I think it was the winner of the Explorer Challenge here in South Australia, a AI challenge, was a couple of guys who had never been in mineral exploration before. They were data scientists, And the first thing they said when they won it, they said, you know, finding ore bodies is really, really, really hard. And it is. It's one of the hardest things you can do. So, yeah, I think it's a continuum of things, of data sets, scales are needed to do this. And we've got such a fabulous investment now happening in pre-competitive that, yeah, you just can't make discoveries without it, which is, I think, Carol's point.
Good. Look, just one more question, and it's actually from me. With Prominent Hill and Carrapateena and now Oak Dam, which really does push the envelope on depth and a number of components of the mineral system, do you think it's time for another book, the Olympic Dam Story sequel?
Oh, yes, yeah, good idea. I must try and get around to that. But I would mention about that book. It was Avi Parvo was very kind to me to enable me to do that. I literally just bumped into him when I was living in Melbourne. He didn't know me from a bar of soap, and I was quite audaciously said who I was. I wanted to write an Olympic Dam story. I wrote a feature story of 1,300 words, and then it turned into a book, which was with his encouragement and support. So he's a big factor in that. But yeah, it'd be great to have another book. Yeah, but it's all time and money, isn't it?
Right. Okay, well, look, thank you again, David, for your time. That was been a fascinating talk, and thanks from all of the attendees today. Thank you very much.
Thank you very much for having me. It's been terrific to have a yak. Thank you. See you.